Okay, so this will be the last section for this lecture. Sorry if this was a little bit on the longer side. I think they should generally be a little bit more concise in the future. But so the idea behind this section is they just introduce these symbols plus and minus infinity, which serve as convenient notation in certain situations, okay? So what I want to emphasize is that they're not numbers, although you can say, like there are certain equations that you can write down that involve the symbols plus minus infinity and numbers, and they usually just act in the way that you'd expect. So for example, so some equations make sense, e.g., you know, x plus infinity is infinity for any actual real number x. So we assume these things, like there's a collection of equations that kind of make sense. And if there's ever any doubt in your mind, it's probably the equation you're thinking of probably won't make sense. So something like infinity over infinity, that is an expression that doesn't make sense. That's an indeterminate form, right? But some things do. Now, so there are some contexts. Here are some of the contexts that we can already use this symbol in for convenience, right? So like something like an interval. So some uses. Intervals. So intervals. You can use infinity as an endpoint. So something like this. And when we use infinity as an endpoint, we basically never use a square bracket. Although if you see something like, you know, b is in, or this could also be like a parenthesis, r union plus or minus infinity. Of course, you should assume that if b happens to be infinity, then the bracket isn't square, it's actually a parenthesis. So, you know, this would indicate a certain class of intervals, or if it was a parenthesis here, then it would be all like half open intervals, including just an entire infinite like ray out to infinity, you know? So these are kind of notations that you'll see, and they just indicate, so this, for example, would be the set of x in R such that x is greater than or equal to a, right? So that's just shorthand. Another use would be to say that supremum of a set A, or let's say a set S maybe, is infinity if S is not bounded above. And similarly with infima, right? The infimum of a set not bounded below would be negative infinity. And lastly, there are some interesting equations you can write down, such as one of the things that's on the homework actually deals with this. But if you define the sum of two sets to be the set you get just from adding all the pairs of numbers from one set and the other, right? So you'd call that A plus B if A and B are subsets of R. There's a homework problem which asks you to prove that the supremum of A plus B equals the supremum of A plus the supremum of B. Now, if we assume A and B are both bounded above, then there's no question about what this equation is supposed to mean, because these suprema are all real numbers, right? So these are all real numbers if both A, B are bounded above. But if either A or B is not bounded above, you can still write this equation down and it still makes sense. So we could make this statement even for sets that are not bounded above. We could make it for all pairs of subsets of R, which is a lot more convenient to say. We can encapsulate all of those. And the way we do that is just say that, well, if A or B is not bounded above, then really, so if A or B not bounded above translates this equation. So the equation translates to saying A plus B is also not bounded above, which is, not too hard to believe, hopefully. So anyway, these are some example uses of infinity and negative infinity, and you'll get used to it if you just practice as time goes on. And if you ever have any confusion about it or uncertainty whether what you're doing makes sense, obviously you're free to ask me or any of your classmates. So yeah, hopefully that does it for you guys, or hopefully that makes it clear. And that'll be it for this lecture. So thank you.